session I am going to explain about series combination of resistance. Let us consider a circuit which consists of three resistors R1, R2 and R3 connected across a voltage source of V volts. This is a DC voltage source, and let the current flowing through the circuit be represented by I. In this series combination of resistance, the same current flow will take place. We can define this series combination of resistance as the circuit in which the same current will be flowing through all the resistors. So the same current I will be flowing through R1, R2 and R3 according to our diagram. This is the circuit diagram. Now what is the combination of resistance? It is a circuit in which the same current will be flowing through the circuit, but the voltage drops will be different across each resistor that is taken. So according to the Kirchhoff's voltage law, KVL, from the diagram we can write the applied voltage from the source V is equal to the summation of voltage drops across each resistor, that is V1 plus V2 plus V3. Now substituting the values of V1 in terms of I and R, V1 is V is what? Current into resistance. So V1 is the same current I will be flowing into the value of resistance in that is R1. So V1 is I into R1 plus V2 is I into R2 plus V3 is I into R3. Now from this equation, if we take I as common, this will be given as I into R1 plus R2 plus R3. And we know that V is always equal to I into R, and this is the equivalent resistance. It can be represented as RS, series combination of resistances. So this diagram can be replaced by a single resistor connected across a voltage source of V volt, same V volt, but the series combination of these resistors can be written as RS, single resistor. This is the equivalent diagram. Now in general we can write if there are n resistors connected in series, then we can write the equivalent resistor RS is equal to R1 plus R2 plus R3 plus R4 plus R5 so on till Rn, and this can also be represented as RS equal to summation of R of J, where J is taking the value from 1 to n. And in this circuit that we have considered, the value of RS is summation of R of 3 resistors are there. So R of J, and J is taking the value of 1 to 3. So this is equal to, from our circuit diagram, RS is equal to R1 plus R2 plus R3. J is 1, substituting J value 1, J is equal to 2 and J is equal to 3. Summation of all these resistors will be the equivalent series resistance. Now one more thing we come across, if all the resistances are of the same value, if all resistors are of same value, then the series equivalent resistance Rf into N resistor can be represented as N into R, where N is the number of resistors and R is the resistance value. Assume that this is of 2 kilo ohm, this is also of 2 kilo ohm, and this is also of 2 kilo ohm. So 2 plus 2 plus 2 is 6. So that we can directly get from this. 3 resistors are there, 3 into each of 2, 3 to the 6. So we will get it as 6 ohm. If each resistor is of 4, 4k, 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 4k plus 4k, 8k, 8k plus 4k is 12k. So how many resistors are there? 3. N is 3 into each of 4k. 3 4 ja 12. So we are getting it as 12k. Thank you.